Hey guys, so today we are going to go over day 3 notes, binary ionic compounds with transition metals, also known as cations. So multivalent cations are going to be found in group B elements. Okay, so in the middle of the periodic table. If you guys remember from your periodic table project that transition metals are part of D block and also F block. Okay, so again, it's part of D block as well as part of F block. Now you do have to be careful because on your periodic table, let me go ahead and pull that up for y'all. So on your periodic table, okay, you also want to consider gallium, indium, thallium, lead, tin, and bismuth as part of your transition metals. Okay, this little ladder that you have right here, this separates your metals from your nonmetals. So anything that's touching your ladder is technically a metalloid. Okay, so they're kind of a metal, but they're kind of not. So those elements that are touching the ladder are going to be considered your metalloid elements. Okay, so if it's not touching your ladder, then it's going to be transition metal. Okay, so again, gallium, tin, bismuth, and then these 3 elements right here. So everything to the left of these 3 elements are going to be transition metals, and as well as these, your F block elements as well. Okay, so those are transition metals. Okay, so again, these are also known as transition metals. I'm going to change to a different color so you guys can see it. So, transition metals. Okay, so if your cation or if your metal is a transition metal, then you must specify the charge with a Roman numeral. So, Roman numeral. Okay, so Roman numerals are these characters right here. So if you have a 1, then that means you have a positive 1 charge. Okay, or a Roman numeral 2, okay, 3, 4, 5, 6, 7, and 8. Okay, you do have to memorize these because we will not be providing that on the test. Okay, so an example of how to use your Roman numeral, well, iron is going to be considered a transition metal. Okay, iron is right here on your periodic table, so that's going to be a transition metal. So because it is a transition metal, it's going to need a Roman numeral. And we're going to represent that as iron 3 sulfide. Okay, so the 3 represents iron's charge. Now, if you notice, on the periodic table, Pb, or lead, is actually in group 4. But if you notice, well, that's not its charge. Okay, the reason why transition metals need a Roman numeral is because their charges are always going to be different. Okay, they don't stay consistent. They change sometimes. Unlike our group A elements, group 1, group 2, and then all these nonmetals on this side, well, they can go ahead and follow our oxidation numbers. Right? Our oxidation numbers are never going to change for our nonmetals, and these 2 metal groups here. Okay, so for again, transition metals need that Roman numeral because their charges aren't always the same. Okay, because there's different kinds of metals too. For example, there's different kinds of copper, there's different kinds of iron. Okay, so that's why we represent them with the charge, because there's different types of those elements. Okay, so just like at the compounds we looked at yesterday, or last week rather, the sum of our charges must equal 0. Okay, and we can still use the crisscross method when writing the formula. Okay, so crisscross crisscross method when writing the formula. If you don't remember the crisscross method, I would look over day 2 notes from Friday, and that's how we learned the crisscross method. Okay, so let's go ahead and do some practice ones. Okay, so if I have copper 1 sulfide, we know that my cation is going to be my metal. So that's going to be copper. Okay, so copper, its symbol is Cu, and according to my Roman numeral, my charge for copper is just going to be a positive 1. Okay, and then my anion is going to be sulfide. Okay, so sulfur's chemical symbol is an S, but let's take a look at our, Okay, let's go back to our periodic table and see if it wants to come up, and it doesn't. Let's go back. Okay, it's not working with me anymore. So on our periodic table, if we take a look, sulfur's oxidation number, sulfur is right here, its oxidation number is -2. Okay, so our charge for sulfur is going to be 2 negative. So the chemical formula is therefore going to be Cu2 and S. Okay, if you don't remember the crisscross formula, remember your charges are going to become the subscript for the opposite element. Okay, so since copper's charge is a positive 1, it's going to become a subscript for sulfur. And then sulfur's -2 charge is now going to become the subscript for copper, okay, which is what we showed here. Okay, so let's try another example. We have manganese 2 oxide. So my cation, remember, is always going to be the first one. It's always our metal that's going to be the cation. So manganese, its symbol is Mn, and according to our Roman numeral, this transition metal has a charge of a positive 2. Okay, and then its anion is going to be oxide or oxygen. And then on our periodic table, let's go ahead and take a look. Oxygen is in group 6A, so its oxidation number is going to be -2, or its charge is going to be -2. Okay, so remember the crisscross method? Our subscripts are going to become our charges are going to become the subscript for the opposite element. Okay, so we're going to have a 2 for oxygen and a 2 for magnesium. But remember, I told y'all if your charges cancel out, then you can just leave them out. Okay, so our final formula is MnO. Okay, because again, if you prefer seeing the crisscross method, so there's our charges, they are going to become the subscripts for the opposite element. So you end up with Mn2O2. Well, that can be simplified, right? We can reduce this by 2. So it's going to be reduced, divided by 2, and you'll end up with MnNO. Okay, so moving on to the next example. Let's see. So we have tin 4 fluoride. So tin, its chemical symbol or its element symbol is Sn. Okay, and its charge, according to our Roman numeral, because it's a transition metal, it's going to be a positive 4. And then fluoride, we just have to check our periodic table. Fluoride or fluorine is in group 7, so it has a -1 charge. Okay, so -1 there. And then still use your crisscross method. So tin is going to have a charge of subscript of 1. And then fluorine is going to have a subscript of 4. So your chemical formula is SnF4. Okay, so that's how you create your formula if you are given the name. Okay, so now we're taking a look at our, we're doing the opposite now. So we are going from the formula to the chemical name. Okay, so this is where it kind of gets a little tricky, and you'll see why in just a second. Okay, so again, you're still going to identify what your cation and anions are. So now we're going to do the reverse of the crisscross. Now our subscripts are going to become the charges for the opposite element. So if iodine has a subscript of 2, then that means lead is going to have a charge of positive 2. Okay, and if lead has a subscript of 1, then iodine is going to have a charge of negative 1. Okay, so again, lead is going to have a charge of positive 2, and then iodine is going to have a charge of negative 1. Okay, so you always want to make sure that your anions have the correct charge when you're working backwards. Okay, so if you're trying to figure out what the chemical name is and you've been given the formula, you always want to make sure your anions have the correct charge. Because remember, your charge for your transition metals could change. It might not be 2 because this could be reduced. Okay, so let's keep going. Let's do a few more examples and you'll see in just a second. Okay, so we know that iodine has a negative 1 charge, right? Okay, because if we look, iodine, does it have a negative 1 charge? Yes. Okay, so my charge for iodine is correct. Then I know my cation for, or my charge for lead is also correct. Okay, so then the name is going to be lead 2, because it's a transition metal, so it needs that Roman numeral, lead 2 iodide. Iodide. Okay? Alright, so the next one, we have iron and oxygen. So remember, your subscripts are now going to become the charges for the opposite element. So iron is going to have a charge of 3 positive, and oxygen is going to have a charge of 2 negative. Okay, is that correct? Does oxygen really have a negative 2 charge? Well, let's take a look at our periodic table. Oxygen is in group 6A, so yes, it does have a negative 2 charge. So this is Fe for iron, and it has a positive 3 charge. Oxygen has a negative 2 charge. Okay, so then the name of this compound would be iron 3 oxide. Okay, all right. So let's go ahead and do the last few. Okay, so this is where you really need to be careful. Okay, lead, according to our formula, has a positive 2 charge, so 2 positive, and oxygen is going to have a negative 1 charge, okay, according to the subscripts. Well, oxygen, remember, we always go based off our anion because our anion's charges never change. So does oxygen really have a negative 1 charge? Well, let's take a look at our periodic table. Does oxygen really have a negative 1 charge? No, it actually has a negative 2 charge. So what that means is you're going to have to multiply both of your charges, so that way oxygen can be true. Okay, so to make this statement true, you need to multiply it, both charges, by 2. So that would mean lead, so Pb, has a charge of 4, because 2 times 2 is 4. Okay, and cations are always positive. And oxygen, negative 1 times 2 is negative 2. Okay, so let's check our anion. Is our anion correct? Is oxygen really negative 2? Yes. Okay, so that means this charge is also correct. So the name of my compound would be lead 4 oxide. Okay, and then the last one, okay, we have cobalt and phosphorus. According to our subscripts, okay, this is a positive one and this is a negative one. Is phosphorus really a negative one? So let's take a look. Our anion, phosphorus. Okay, phosphorus is in group 5A, so it actually has a charge of -3. So how can we make this statement true? We're going to have to multiply it by 3, okay, which makes cobalt a charge of +3, and phosphorus have a charge of -3. Okay, so again, is phosphorus really a -3 charge? Well, the answer is yes, because we know we know that all from our periodic table. Okay, so our name of this compound ends up being cobalt 3, 1, 2, 3, and P, okay, which is phosphorus. So phosphide. Okay, so again, to figure out the charge of your transition metal, just uncross your charges. Okay, because remember, your crisscross rule, charges become subscripts of the opposite element. Okay, so charges become the subscripts of the opposite element if you are doing this way, if you're trying to find your formula. Okay, so if you're trying to find your formula, your charges are going to become the subscripts for the opposite element. But if you're trying to figure out the name, you're going to, your subscripts are going to become the charges for the opposite element. Okay, so again, if you're trying to find the formula, your charges are going to become the subscripts for the opposite element. Okay, but if you're trying to find the name, then your subscripts are going to become the charges for the opposite element. Okay, so like iron, the subscript is 2, so it's going to be oxygen's charge. Okay, and then oxygen's subscript, which is a 3, is going to become the charge for iron. Okay, so it's just crisscross and uncross. Okay, and then this is also something that you need to know. This is very important. These 3 metals do not need a Roman numeral. Okay, so zinc, silver, and cadmium. Okay, so it's these 3 on your periodic table. So zinc, cadmium, and silver. So an easy way to remember what their charges are. So zinc is a +2, silver is a +1, cadmium is also a +2. Well, if you take a look at your periodic table, well, silver is a +1 charge. Cadmium and zinc are a +2 charge. Okay, so it'll only work for these 3 because they are the exception. Okay, your other transition metals, there's different variations of them, so they have different charges. Okay, so that's why we need the Roman numerals for the other transition metals. Okay, all right, so if you have any questions, please don't be afraid to ask. Okay, and if you didn't understand anything that we did today, please view the other videos from day 1 and day 2.